We've seen that the map function is really useful. It lets us transform a number from any range into any other range. It often happens, though, that the input range is 0 to 1. If that's the case, you can use a shortcut version of map called Lerp. It's just like map, but you don't give it the input range. It assumes that the value you're handing it is in the range 0 to 1. Suppose that this is our input range. This is a bunch of numbers running left to right, and this is our output range, just like when we were talking about map. We'll say that our input range runs from 0 to 1, and our output range runs from S to E, standing for start to end. We have a value v somewhere between 0 and 1, and we want to find its corresponding value between S and E. Of course, we can do this with map. We say map and then give it 5 arguments, the value v, the input range 0 to 1, and the output range S to E. We can get rid of these 5 arguments and replace them with just 3 by using lerp instead. Now, I wish that the 3 arguments to lerp were v, s, e, and you just left out the 0, 1. That would be clean and clear, and that would be the end of it. But unfortunately, that's not how it is. Those 3 numbers are used, but they come in a different order. The first argument is s, the second argument is e, and the last argument is v. This is really a shame, but it's just the way things are. It's just one of those things you commit to memory and don't worry about. What lerp is telling us is that we have a starting value s, an ending value e, and a value v between 0 and 1, and it returns a new number between s and e. Before we push on, you might wonder where this weird word lerp comes from. It's actually just a squished together version of how mathematicians describe this operation. When we do this mathematically, it's called a linear interpolation. And nobody wants to say linear interpolation over and over again. So we squish it down and we just call it lerp. Let's take a look at lerp in action. Here's a little sketch where I've put 4 shapes in the corners of the graphics window, and there's one shape in the middle. The shape in the middle is actually following my mouse, and as I move my mouse around, that shape changes. And it becomes like the objects in the corners the closer I get to the corners. So if I go up into the upper left corner, it becomes a large orange circle. If I move down, it turns into a large orange ellipse. If I move to the right, the ellipse gets smaller and bluer, and as I move back up, the ellipse turns into a circle. And completing the loop, if I go to the left, the circle becomes more orange and bigger. And I can go anywhere in this space, and I get a shape that is of the correct shape between a circle and an ellipse, the right size between large and small, and the right color between orange and blue. The easiest way to write this program is to use a combination of map and lerp. Let's see how to do it. First thing is we make a little drawing of what's going on so we can refer to it. Normally I would just doodle something up on paper, but let's do it on the computer. Here's our graphics window. In the upper left, we'll have a big circle. In the upper right, we have a smaller blue circle. In the bottom left, we'll have a big orange ellipse. In the bottom right, a small blue ellipse. So how can we categorize what's going on here? First of all, we can say as we go left and right, we're changing color. When we're at the far left, the shape we want to draw is orange. When we're at the far right, the shape will be blue. The shape also changes vertically. When we're near the top, it's round, like a circle, and when we're near the bottom, it's squashed, because it's an ellipse. There's also another change horizontally, and that's in size. When we're near the left, it's big. When we're on the right, it's small. So now, how do we take this information and write a program that will draw the correct shape? So how should we organize this program? I'm going to create a mouse handler. I'm going to put it inside of mouse dragged. Every time the mouse moves, I'm going to create 2 global variables. I'm going to take the values of mouse X and mouse Y and hand them to map and get back a value between 0 and 1 that tells me where I am horizontally and where I am vertically. Then inside of draw, I will use those 2 global variables between 0 and 1 to create the right shape to draw. Let's take a look at these 2 steps. This blue box represents the lines that go inside of mouse dragged, and it has two calls to map. The first one maps mouse X. This map statement is doing something wonderful for us. It means that we no longer care about the size of the graphics window. If I make the graphics window twice as big, then width goes up by 2, but the result of mapping is still I'm 0 at the left and 1 at the right. My draw routine only says, hey, XA goes from 0 to 1, and it tells me where the mouse is horizontally. And of course, I'll do the very same thing vertically. I'll take mouse Y, and I'll map it from the range 0 to height to the range 0 to 1. Now I have two global variables, XA and YA, both between 0 and 1, and they tell me where the mouse is. If I take them as a pair, 0, 0 is in the upper left, 1, 1 is in the bottom right, and values between 0 and 1 are inside the rectangle. That all goes inside of mouse dragged, and that's all mouse dragged does. Now, let's think about what happens inside of draw, and that will be inside of this green box. There are three things we need to know in order to draw the right shape. We need to know the radius of the shape, the fill color of the shape, and how squashed it should be. So let's take care of those one at a time. What should the radius be? By radius, I mean the horizontal radius. The ellipses will have a smaller radius vertically. They get squished. But I'm just worried about the distance from the center to the right-hand edge. Looking at the sketch, we can see the radius is big when we're at the left-hand side and small when we're at the right. In other words, when XA is 0, we have a big radius, and when XA is 1, we have a small radius. Well, that's just a Lerp statement. So if I have some variables called R big and R small, which are just numbers that I'll pick out of the air, maybe 20 and 10, to refer to the size of the radius, then this statement gives me back a floating point number between R big and R small, which is scaled by the horizontal position of my mouse. And notice, because I'm using the global variable XA, which was set up inside of mouse dragged, I don't care what the size of the graphics window is. I just have a number between 0 and 1. Well, I can do the very same thing for the squash factor. That depends on the vertical position of the mouse. So I'll lerp a couple of numbers. And for specificity here, I'll actually name the numbers. I'll put them in here rather than using variables. And I'll say that when we're at the top of the screen, the squash factor is 1. The thing is as tall as it is wide. And down at the bottom, the squash factor is a half. It's only half as tall as it is wide. And we get back a number between 1 and 0.5 as we move vertically because we're lerping using the value YA, which again always runs from 0 to 1. Finally, we want to change the color. And rather than use Lerp, we use the built-in Lerp color. There's a whole video on Lerp color, but here's the basic idea. The built-in Lerp color takes two colors. Here, orange and blue are color variables that I've created that I've filled up with the RGB values. Lerp color takes those two variables and a number between 0 and 1 and gives us back a new color. So here, fill color is a color variable. So let's see this in action. I'll push everything off to the left and now look up at the graphics window and suppose that our mouse is right here. Now I'm not drawing the correct graphics object, I'm just showing you where the mouse is by drawing this bright pink dot. Suppose we got here by dragging the mouse. Well, so the first thing that happens is mouse dragged gets called. And mouse dragged first takes the value of mouse X and does map with it. That gives us back a number between 0 and 1. One way to think about that is that mouse dragged is drawing this horizontal line, and we're finding out where the mouse is on that horizontal line as a percentage, where it's 0 at the left and 1 at the right. So let's bring that line down and just kind of eyeballing it, we might say it's about 7/10 of the way across. So the result of this first line is to set XA to the value of 0.7. The second line we can think of as drawing a vertical line through the mouse location and finding out where the mouse is vertically on that line. And I think it's probably about 40% of the way down from the top. So YA is 0.4. Now we have these two global variables ready for us when we get to draw. So now let's look at draw. The first line sets the radius from big to small using XA. So using the things I have above, we're saying 70% of the way from the big circle to the little circle. So let's draw that. The second line computes the squish factor, and it uses YA. And YA is 0.4. So we're going to go 40% of the way from 1 to 0.5. Well, so that's nearly halfway, so let's change our circle in the graphics window to become a little squished ellipse. Finally, we have Lerp color, where we're going to use XA again and go 70% of the way from orange to blue. And looking back up at our graphics window, I'll go ahead and change that. So now we have a more bluish kind of an ellipse. And we've now used map and lerp to draw our ellipse. The beautiful part is that things are so nicely separated. You have the two calls to map inside of the mouse handler, so every time you drag the mouse around, XA and YA get recomputed, and they're always between 0 and 1. Then every time draw gets called, we use XA and YA with lerp, which keeps things nice and simple, to determine the radius, the squash factor, and the fill color, and then we draw the shape. Using lerp lets you keep your code a little bit simpler. You're typing a fewer number of variables, there are fewer chances to make typos, there are fewer chances to make mistakes, and that's always a good thing. It can also make your program read a little bit more clearly because you don't have to think about, oh, what is the input range? Oh, it's 0 to 1. If you see lerp, you know that's the case. Just as much as I've encouraged you to get used to using map, get used to lerp. If you're already used to map, you'll find that you get the hang of lerp in no time at all. Like map, lerp is a terrific thing to have in your little box of personal tools because it lets you create relationships. So you might create an entire interactive animated thing based on one variable like frame count or mouse X. By using map and lerp, you can take that one variable and transform it into other ranges to control other variables and create rich and interesting motion.